Okay, good morning. So let us start the lesson. So trigonometric functions. Today we want to talk a little bit about these functions. Of course, in the book we have three of them. I can write a function f of x is equal to sine of x, and then g of x. Let me call it in a different name. G of x is cosine of x. And the other one, let me call it h of x, is tangent of x, yes? Yeah, we wanted to talk a little bit about the properties of these two functions in this lesson and in the next lesson. That talking about tangent is a little bit more technical. We'll talk it later in the book. I don't know, because I want to follow the book. The book has started talking about functions without first introducing the notion of radians. Okay, but if I want to go back and forth, maybe I will get you make you confused. So let me just follow the order in the book. Okay, so we just want to talk about the trigonometric functions, but still we measure angles in degrees. Okay, that's the only units. That's the unit that we have. We want to work with that. Of course, there are some properties of this. I cannot rigorously prove it for you, but you need to trust me on that. So we have some properties of these functions we want to explore today. The first and important thing is that these two functions, so let me clean this one. So our talk would be only about sine and cosine functions. These two functions are periodic functions. So what is the meaning of a periodic function? Let me just write the formal definition here for you and then see why this is the case. So definition. Let f be a function with domain df. D sub f, yes? Do you remember what the domain is, yes? For example, if I have a function f of x equals to x squared, the domain of this function is the set of all real numbers. What does it mean? It means that I do not have any restrictions for the inputs. I can put any number that I like for x squared, and this will give me a number at the end. But if I give you this function, the domain is clearly not the set of all real numbers, because I have a small restriction here. I cannot put 0 for x, because if I put 0, I will not get any outputs. So here I would say that the domain of f is the set of real numbers. But if I ask you what that is, this is now that you know set theory, so you can write the set of all real numbers minus the set containing the 0 number. Yes. So the domain, what do you remember? We have this in Math 5. A minus B is the set of all elements inside A, but not in B. So this means that the set of all numbers that are in here, but they are not here. So this is another way to say it is not 0. But be careful. When you write x is not equal to 0, this is a condition that you put on the domain. Domain in mathematics is a set. So you have to respect the language of set theory if you want to express it, yes? So you can write it in this way if you want to. You can write the domain of G is the set of all x's which belongs to the set of real number, but such that x is not equal to 0. That is also completely okay if you write the domain in this way. Because domain in mathematics is a set by its definition. Either you use this notion of subtraction of sets in this form, or you can just describe your sets. But if you just, in Math 2C, it was okay if you write x is not equal to 0, but here you need to respect that. Okay? So anyway, the notion of domain is simple. For example, let me clean this. If I give you another function, can you write the domain of this function for me? What is the domain of this function? don't be distracted by the notion of the domain, even though the notion of the domain is important for the next chapter. But here, I just want to remind you about the domain. So if I ask you what is the domain of this function, I am asking you what are all possible values that I can substitute for x to get a meaningful expression. Yes. For example, I can put x equal to 7 because 7 minus 2 is 5. The square root of 5 is meaningful. But I am not allowed to put x equal to 1 because 1 minus 2 is minus 1. Square root of minus 1 is not defined. Yes? So that's the mean. So can you tell me what is the domain of this function? If I want to write it in the language of set theory, I would say the domain of f is the set consisting of all x's coming from the set of real numbers, but not all of them. The ones that have one property. What that property is?
The x is equal to or greater than
2. X is equal to greater than or equal to 2. If you remember, by the way, it's good to remind you, these sets are so famous in mathematics, they called them, I told you about it, they are called intervals. Yes, if you remember, go back to study the set theory. So, and then there is a symbol to denote that. So you write square brackets or just normal parentheses. Parentheses means that you are excluding the point, but when you use a square bracket, it means that you are including the point. Here I am including the point, but of course I do not have any upper bound, so you need to write infinity and write this. So whenever you see this symbol in mathematics, it means this set. In one of my lessons, I just talked about this briefly, about intervals, yes? Okay, so you understand what is the meaning of the domain. Domain is the set of all values that you can use as input for your function. Yes? Okay, so now let f be a function with some domain df. F, the function f is said to be periodic if there exists a real number. I'm talking about functions on real numbers. Okay, a real number t, capital T, this is the symbol we use for period. So a real number t such that f of x plus t is equal to f of x for all x belonging to the domain of this set. This is a very formal definition of a periodic function, but let me just describe you what does it mean in simple words, of course. So a periodic function is a function that you can somehow manage to find a number t so that if you calculate f of x plus that number, it doesn't affect anything. It becomes exactly f of x for all choices of x. For example, it might be a little bit hard to understand. The function sine of x is periodic. Why? Because f of x is sine of x. Let me ask you to calculate this. Let me choose any x that you like as an angle, and add 360 degrees to it. Okay, so I have a function. I ask you to choose any x that you like. So you choose x, any x, and you add 360 degrees to it, whatever it is. Let us calculate to see what this is the case. So if I ask you to calculate f of this, what you're supposed to do, if I ask you what is f of 180, and you answer me, what is f of 180? If this is f of x, what is the meaning of this symbol in mathematics? Yes? I need to replace x with 180 everywhere. Yes or no? Okay, so I go here and replace x with 180. This becomes sine 180. If I have it in my memory, it becomes 0. So the answer to this question is 0. I say the value of the function f at this number is equal to 0. If I change my opinion, I ask you what is f of 90 degrees, what you are supposed to do. You go to your function, you replace x with 90 degrees, and if possible, you calculate that. So I do this. I take x with 90, sine of 90 is 1, f of 90 degrees becomes equal to 1. Is that understandable? So you need, by the way, I don't know how much you know about functions or remember, you need to consider a function as an operator or a machine that takes from you an input, do some operation on your input, and gives you an output. This is the best way to imagine a function. Okay? So you need to understand this in this way. F is an operator or a machine that takes a value like x. What is the role of this operation? When you put the x into the machine, it takes sine of that input and then calculate that sine and gives the number out. And that number is the output. Yes, that's the way that you need to think about the function. So function is an operator. So let me call this one f. I have an input. I get something out, which is called f of x. This is the best way to imagine a function. Yes. So you have a box. You don't know what's happening inside, but you send something to it, and then you get something out. Be careful. F of x is not the function, even though most of the books say that let f of x be the function. This is a wrong word. Yes, you need to see that this is the machine itself is f. It's exactly like that. You have a meat grinder. You put meat into it, and then you get minced meat. And then so the minced meat is f of x. The meat that you put is x. The machine itself is the function. Okay, so that's the difference between the machine and the product of the machine. Yes? So be careful. That's a good, but I will talk about functions later. But if I ask you what is f of x plus 360 degree if this is my machine, it means that now this is playing the role of my input. So the whole expression is my input. So what I have to do, the function has this role. Whatever you give to the function takes sine of it and gives it back to you. So this one, the input is this one. So the function will take your input and make sine of it and give it back to you. But now imagine your trigonometric knowledge. What is the answer to sine of x plus 360 degrees? Yes, everyone? It's sine of x, yes? Because if I have any angle, wherever it is, it doesn't matter. If I go one full round, I will reach the same point. So the x and the y coordinates remain the same. So that is clear that this becomes exactly equal to sine x. But now if I ask you, what can I write for sine x? You see it on the board, it is f of x. So if you do not look in the middle, you see that f of x plus something is equal to f of x for all choices of x. And this can play the role of this t here. So I was able to find the t with that property. Of course, the number of functions that are periodic are very limited. For example, is f of x equal to x plus 2 is a periodic function? It seems no. Why? For example, assume that it is periodic. I want to find, is it the case or not? So it means that I need to look for a number so that if I calculate this, it becomes equal to f of x, not for one value of x, for all. This means for all values of x. Yes? Okay, now tell me, what is f of x? It is x plus 2. What is f of x plus t? Can you tell me? What is the role of this operator? Whatever you give to this operator, it will take your operator, add 2 to it, and give it back to you. Yes? Now I have given x plus t to my operator. It will do the same thing on this new input. So what would be the answer? Yes?
X plus t plus 2.
2. Yes, the input x plus t. So let me wait a little bit. Is that understandable for everyone that I wrote for this one. I am replacing x with my new input everywhere. Yes or no? Okay, and then what happens? This one and that one are gone. Then this one and that one are also gone. So what is this one? T is equal to 0. But of course, I should mention, be careful, if there exists a non-zero. Of course, the 0 is so trivial because if t is 0, that's nothing. Every function has that property. I was careless. Because if I allow for t equal to 0, then every function is periodic because you can choose t equal to 0. Sorry, I have to write this. Okay, so this function is not periodic, yes, because it gives you that t has to be equal to 0, but t cannot be equal to 0. So, for example, this function is not periodic. We argued, actually we showed that it is not possible to find a non-zero real number with that property. But this function was periodic and we found that. By the way, here, if I ask you what is this one, what would be your answer for this function? This becomes sine of x plus 720 degrees. Understandable? But now, can you tell me what is the answer? Can I write something simpler than this in front of it?
Sine of x.
Sine of x again, because I am adding 720, 2 full rounds. I go back and reach to the same point. So the point is not changed. So this becomes exactly sine x. Okay? So this is why you see that if a function is periodic, you don't need to find one single value that has that property. This is why I continue this definition. The smallest positive number t with this property is called, if it exists, but let me just, if it exists, you don't need to be worried about that, but if you want to properly mention it, you have to write it down. If it exists, is called the, sometimes people call it fundamental, but you don't really need to because it is not in the book. Fundamental period of the function. Okay? So here, let me ask you some questions. So 360 degrees actually worked for this case. 720 degrees also worked for that case. Do you think that you can also find a negative number that works fine for sine x? Do you know any negative number with that property? Yes or no? So I chose two positive numbers, 360 degrees, it worked. 720 degrees positive also worked. Now I'm asking you, can you also think about a negative number with that property?
Minus 1080.
Yeah, so the simplest possible.
No,
That's correct.
60.
Minus, yes. So you can write, if I ask you what is f of x minus 360 degrees, it becomes sine of x minus 360 degrees. But do you agree that this is also equal to sine of x? Yes? Because what's happening now? You are going one full round this time in the negative direction. So again, you come back to the same point, and when you come back to the same point, the sign doesn't change, yes? Is that clear? Okay, so can you immediately guess how many numbers you can present? How many positive numbers you can present here with the same property? How many? Infinitely many, yes? You can just add one round into it. And how many negative number you can imagine? The same. So for example, if I want you to write a list, I would say minus 720 degrees, minus 360 degrees, 0 degrees, and then, I don't know, 360 degrees, 720 degrees. I get a long list of possible numbers. But of course, let me exclude this because this works for all functions, not just for this one. So this is why we excluded that. So if you don't care about this, you have infinitely many negative numbers and you have infinitely many positive numbers working for this function. Now, if I ask you what is the period of that function, I mean one single number if possible. You need to remember the definition. The smallest positive number t with that property. So if I ask you what is the fundamental period or the period of this function, you cannot answer all of them. You have to answer exactly one of them. So if you say 720, it is wrong. You will not get any points, yes? So what is the smallest positive number in your list is 360 degrees. And that is called the period. Okay? That is called the period. Okay, let me test your understanding about this a little bit subtle definition, because you might think that this is easy, but it might be confusing. Can you tell me what is a constant function? Do you remember a constant function? What's the meaning of a constant function? Yes?
That the gradient is constant.
F of x is equal to a constant number. That's a constant function. Let us pick one of them. For example, now I'm asking you a question. F of x is equal to 5. It is an example of a constant function. Now I am asking you, do you think this constant function is periodic? If this function is periodic, what is the period of this function? This actually is a little bit higher understanding of mathematical rigor. Yes, Kevin? First of all, periodic, yes or no?
Yes, I would
Yes.
say.
Yes?
But I have a question in
Yes.
return.
Yes?
Smallest natural number or
No, smallest real
real
number.
number?
Yes, yes.
Because then it would be impossible to say.
Exactly. So you answered completely correct. So you answered that the function is periodic, but there are no periods for this function. This is why I just want you to understand this sentence. Of course, don't worry about these small differences. These are not the topic in the book, but it is good to digest some mathematical concept. Let us go a little bit around them. So f of x is equal to 5 is periodic. Why? For example, if I ask you calculate f of x plus 1, what would be the answer? If the function is constant, it means that it doesn't care about you at all. So you put x, it will return you 5. If you put 1, it gives you 5. If you put 1000, it gives you 5. That's the meaning of constant function, yes? So now I am asking you, if my function is this constant function, what is f of x plus 1? Can you tell me? What should I write here in the box in front? Yes?
5.
5, because I told you that this function is actually selfish, it doesn't care about you. So whatever you put this, it will return you 5. So f of x plus 1 is 5. But is it equal to f of x itself? F of x is 5, f of x plus 1 is also 5, so it's equal to f of x. So by comparison, you see that t here is played by this 1. So this is a periodic function because I was able to find a non-zero number, in this case 1, so that this property holds for every choice of x. Yes? Understandable? Yes or no? Let me ask you, what is f of x plus a square root of 3? What's the answer? That's also 5, and that's again equal to f of x. Now, the square root of 3 is playing the role of that t. Yes? So if I ask you what is f of x minus 2, the answer is again 5, and that would be again f of x. Here, minus 2 is playing the role of that. So now if I ask you, can you list all possible numbers for this function? What do you list? What do you list? Yes?
The set of real numbers.
The set of real numbers. All numbers that you can imagine will be in your list. You take the 0, 1 away, but of course you have infinitely many of them left. So is the function periodic? Yes, because I need only to find 1. Instead of 1, I found infinitely many. But Can I talk about the smallest possible real number? No. Which one? Which number is the smallest real number? We don't have the smallest positive real number. Is that understandable? If you say 1 is the smallest, it is wrong because 0.5 is a smaller. Is 0.5 smaller? Smallest? No, because I divided by 2. There is also another smaller. So you see that this is a function which is periodic, but you cannot talk about the period. Yes? There is no smallest one. Is that understandable? Okay, so that I just want you to understand. I wanted you to understand these sentences, but that is not part of your lesson, even though it was not hard. I believe you could understand it. Yes? If you don't, and if you are interested, ask me questions. Understandable? Okay. Now, for the time being, we want to talk about these two functions, f of x and cosine x. Sine x and cosine x. Can you talk about the domain? The period of this function. Do you think cosine is also periodic? And if it is, what is the period? Okay, but let us just repeat. There is nothing new in cosine. But then I will talk about tangent. We will talk a little bit. We can talk about the period of tangent today as well, because I think they are good. They are nicely related. So let us more or less repeat everything to have a deeper understanding of the period of cosine. First of all, tell me, do you think cosine is periodic? If it is, can you talk about the period, the smallest positive number with that property? I'm waiting for you. Who wants to answer? No one? Yes, Gabby? First of all, is cosine periodic?
Yes.
Yes? Okay. So can you elaborate why do you think it's periodic? Because, for example, this is the okay.
If you imagine the unit circle,
Yes.
If you add 360 degrees,
Yes.
you would again have the same x coordinate.
Exactly. Thank you very much. So it becomes cosine of x plus 360 degrees, and then it becomes cosine x. This we learned in trigonometry before. Okay? Yes? And then I am calculating something new based on my previous knowledge. If you don't understand one of these inequalities, please ask me. And this is exactly equal to g of x. So, for example, I was able to find 360 degrees so that g of x plus 360 degrees is exactly equal to g of x for every possible choices of x. Is that understandable? So this shows you that g is also periodic. What is the period? What is the period of cosine? What is the period? 360 again. Yes? It's clear, but this is not very clear. You need to convince yourself. Why do you think I cannot find a smaller? You can just go to your intuition in trigonometry. If I have one angle, say here, x, if I go one full round, be careful. If I go one full round here, this is clear that I will return back to the same point, so the x coordinates are the same, so I will have the same cosines. That is for sure. But do you think that it is also possible to find a smaller than 360 degrees? Because if you want to say it is periodic, you don't need to be very careful. You just find one that is enough. But if you want to find the period, you need to convince yourself that this is the smallest positive one that you are answering. You also have to convince you of that one as well. Periodic, being periodic or not, we finalized it here. Yes, it is periodic. But do you think I can find some positive number smaller than 360 degrees which play the same role? Yes?
360 minus x, but it doesn't apply to all. 360 minus x.
No. You're not allowed to change the sign of x. You are allowed to play with the sign of t that you are adding.
Yeah, but I mean x plus 360 minus x. So
No, x is not a number. By the way, might be. So this t should be independent of x. It should be a number without dependence on x. Okay, without any dependence on x. Can I find something smaller with that property? No, yes, we cannot find anything, because if you start from here, if you go one full round, you will end up at this point. But you might say that I will go smaller because my goal is to make the cosines the same. If I end up somewhere here, this is not clearly true because the x coordinates are different. But you might think that why not? I can come up from here up to here, and then the cosines are the same. So definitely this angle is, whatever it is smaller than 360 degrees. So do you think that I can find something smaller? Yes?
Not for all cases.
For all cases. That's very, very, so your understanding of these phrases are very good actually. So, so that is working. This one is only working for this x. Okay, but if I change my x, and this point should also change. So this depends. If you say this mirror image of this point, yes, for this particular x, the mirror image also works. But the mirror image only works for that particular value of x. If I start changing my x, the mirror image start moving around. Okay, but t should be independent of my choice of x. I need to find a t that works for all x's simultaneously. So this is why if you have that restriction, you cannot make it smaller. Even though for one particular case, you can make it smaller. Is that understandable? So that is the deep meaning of a periodic function from a rigorous algebraic point of view. Any questions so far? Okay, let us talk about tangent. This is a good opportunity for you to deepen your knowledge about the period of functions. So, for example, let us talk about the period of tangent. So, here, this is you need to memorize. This is really important. If someone asks you what is the period of sine function, 360 degrees, what is the period of the cosine function, 360 degrees, yes? Let us talk about, if possible, first of all, is tangent x is also periodic? This is the first question. For this, answering this question, you don't need to be very careful. You just, if you find a number which works, that is it. But if you want to answer the period, you have to be careful. Is it the smallest positive one that I am answering or not? What is your intuition? Do you think tangent should also be periodic? Intuitively. Its tangent is also periodic. I want you to understand this because it's good to understand deeply to answer quickly. So, what is the meaning of a periodic function? A periodic function is a function that if I add something to x, it will not change the function. Yes? Yes, so it means that periodic is a function which is somehow conserved. Okay, it doesn't change if I do an addition to x, like t. Okay, so what is your intuition about tangent now? Yes?
My intuition is yes, it is periodic.
Why?
Okay, so we've just discovered that sine is periodic and that cosine is periodic. And the tangent function consists of them divided by each other.
Exactly.
So it should be.
Yeah, exactly. Because if you change x to x plus 360 degrees, we just learned sine will return back to itself. Cosine also returns back to itself. If sine and cosine go back to themselves, so sine over cosine, which is the definition of tangent, which definitely goes back to itself. Yes. So let me if I want to say what do I mean? I mean this. X plus 360 degrees. This means sine of x plus 360 degrees. So these intuitions in deeper understanding mathematics is really important. But we just learned that what can I write for the numerator? I can just simply write sine x. What can I write for the denominator? I can simply write cosine, but still I know what is this. This is tangent of x. So I succeeded. I succeeded to find a number so that for all possible x's, tangent of x plus 360 degrees returns back to tangent x itself. This is finished. Tangent of x is periodic, full stop, yes? But the question is that, what do you think about the period of tangent of x? By this question, I mean, can you find something smaller even though it's still positive? Yes? Yes?
Okay, so if you add 180,
Yes, exactly.
sine of x should become negative, and so should cosine of x.
Yes, because here, if I go to 180, what happens? Sine x doesn't go back to itself. Let me calculate this one for you. If I want to calculate this one for you, it becomes sine x plus 180 degrees divided by cosine of x plus 180 degrees. Of course, sine does not go back to itself, but if you remember, I don't know, addition formula or symmetry arguments, you immediately realize that it will go to negative sine x. So sine didn't return back to itself. But I don't care about sine because I'm talking about tangent here. And then, fortunately, cosine also does not return back to itself. It goes to cosine x, either by addition formula or symmetry arguments. And then the good point is that because coincidentally tangent is defined in this nice way, these minus signs are cancelled, and what I get is again tangent of x. So even though I started with 360 degrees and I got tangent, but I still can't find a smaller number. And that is 180. So if there is a competition between these two to win the periodic of this function, that would be by this one. But you might say that, can I still make it smaller? Yes or no? No, because so in principle, you need to know a little bit of trigonometry to be able to convince yourself that no, it is not possible to make it smaller than 180. So that is the take-home lesson today. Actually, is that sine, cosine, and tangent, all three main fundamental trigonometric functions are periodic functions, but they are very similar together. The period is 360 degrees. But the period of tangent is 180 degrees. Okay? So it doesn't mean 360 degrees does not work. It works, but it's not the smallest one. The smallest one is 180 degrees. Yes or no? Okay. Now let me ask you one more question about understanding this periodic function. If t is the period of this function, or a period, it doesn't matter. What can you say about this? Can I write something in front of it? T is any period that you like, the fundamental one or a non-fundamental one. I multiply it by 2 and add it to x. Can you write something in front of it? I multiplied by 3. I multiplied by 4. Yes.
If it's truly a period, it should just become f of x.
F of x. Why is that? Because f of x plus 2t means f of x plus t plus t. Yes, I can imagine that this is capital X in my head. F of x plus t, but t is the period, a period of f, so it will not affect this calculation. It becomes f of capital X. But what is capital X? Capital X is x plus t, but again t is the period, a period, so it becomes f of x. So it doesn't matter how many periods you add. It doesn't matter. So what can I write? I can write f of x plus any number n multiplied by t is equal to f of x. Of course, nt is not the fundamental period because I want to find the smallest one, but for all n's it will work. And of course, you can also have negative numbers. F of x minus t is also actually the same. This might be a little bit harder to show. What is f of x minus t, by the way? Is it also f of x? But why? Yes, because we told that if I add something, it will not change. It was reasonable. But what do you think if I subtract, it does not change? Yes, Amanda, this time.
Like x plus parentheses minus t, and then that becomes just f of x.
No, we don't know yet. We know that if I add to it.
Minus t.
Okay, but if t is a period, we don't know minus t is a period unless you show it. But that's exactly what I want to show. I want to show that if t serves as a period, minus t also serves as a period, which is not clear yet. That's exactly this question. So there is no way to find it from this, I think. So f of x, so we know if unless I put this definition in the definition of a periodic function. Yes. So in the definition, I didn't want to make it complicated. So might be the correct definition is that plus or minus t. Both of them should work. Yes. But if I wrote it plus and minus t, might be I was confusing you. But if a function is really periodic, it doesn't matter it doesn't matter if you're adding a period to it or subtracting a period from it. Okay, you will see what is the meaning. Let us. In the case of these functions are very simple. Yes, if x plus or minus 360 degrees, both of them are actually going back to cosine. Okay, so before talking about that, I want you to understand this is the main topic of the lesson. We want to know a little bit about the graphs of these functions and to see how the period, how by looking at the graph of a function, you realize the function is periodic. Okay, so using algebra, you more or less learn. That is enough for your level of lessons. Okay, but if I give you a function, no, I don't give you the function, I give you the graph of the function. How do you think by looking at the graph of the function? Of course, in principle, you cannot be sure, but assume that the graph continues like that forever, and you see this in front of your eyes. How do you realize by looking at the graph the function is periodic or not? By the way, the name periodic is not a misnomer. It's a really meaningful name. So in physics, you have learned about periodic motions or not yet? Have you studied periodic motions? Okay, but periodic motions are, so it is clear that, for example, if something repeats itself exactly the same in the same time intervals, that's a periodic motion. For example, the motion of a pendulum, an ideal pendulum, it goes back and forth forever, okay? So it's repeating the same motion on some period of time. I don't know. If it takes 2 seconds for the pendulum to come here to here, it goes back 2 seconds, 4 seconds. So every 4 seconds, it will be the same place, You don't need to know the history of this pendulum to predict its future. You just need to start from here and predict what is the future of this pendulum. Yes? So everything that repeats itself is actually somehow related to periodic function. It means that if you know a little bit of physics and you start writing the equation of a pendulum to find the position of this bulb after, do you call it bulb or bulb? Whatever, bulb, okay. So then if you want to find an equation to locate, to be able to locate the position of that bulb in time, that would be definitely a periodic function because it is repeating itself. And you will see that in the physics, you will see that's a sine function or cosine function. Okay, so it's also extremely important, this lesson in physics. Periodic is actually not a misnomer. So that is the meaning why we call it periodic, because it repeats itself. And that's exactly the case for the graph of the function. It means that one part of the graph, whatever it is, depending to how large the period is exactly repeating itself. It's a copy-paste of, so the whole graph is a copy-paste of one part of the graph repeatedly, to the right, to the left. That's the meaning of a periodic function. So if you see that, for example, I cannot draw it perfectly fine, but so if you, I don't know, for example, if you see it something like this, I try to, they should be identical, okay? I cannot draw them identical. So this direction, okay? So that is a periodic function, assuming that this is going forever. This graph is definitely, if I do it precisely, you can imagine what I mean. If I do it precisely, that would motivate you that the function for this graph is a periodic function, because the whole function is the copy-paste of one portion of the graph. That is also extremely important to realize which portion. Be careful about this. I want to, these are exactly at the lesson. Can I say that this portion, if I copy and paste this portion, do you think that I will generate this graph? No. Because if I copy and paste this portion, it would be this. Yes? So it is not this part that is being copied and pasted over time so that I will get this blue curve. So which portion is that? So for example, this one, do you agree? If I start copy and pasting this part, I will generate this one. Yes or no? And then this length is the period. Okay, and that is exactly what I am adding or subtracting without any changes. Yes? So that is exactly the period. Okay, can you tell me another portion that I am copy and pasting to generate the same? This is not unique. This one was good. Can I imagine another copy and paste portion so that it also generates the same graph? So let me clean this. Okay, so can you imagine another portion that is by copy and pasting, it will generate the whole graph? Yeah, it is not hard. So for example, I start from here, okay, and then I go here to go up to here. Agree? If I start copy and pasting this red part, again I generate the same thing. But the important thing is that if I ask you what is this length is again t. So do you understand? So here I have shifted a little bit. So I started from here first up to here. This is the period of the function. Now I started from a little bit ahead and then I went up to here. But the point is that it doesn't matter how you copy and paste. If it is supposed to generate the whole graph, you cannot make it smaller than the period, the fundamental period. Yes? So finding the fundamental period. Why it is called the fundamental? Because I cannot make this shorter than that. But can I make it longer than that? It is clearly yes. For example, do you think that if I consider this up to here, Do you agree by copy and pasting this one, I also can generate the whole graph? Yes, but what I am making it longer. This is not t, even though this is also correct. But compared to this length is longer. So if I want to talk about the period, I have to choose the smallest possible length so that the corresponding graph on top of it, by copy and pasting, generate the whole graph. Yes or no? Yes? So that is actually a periodic function. So this is extremely important in exam. So a function is given to you. By looking at the graph of the function, you should be able to read the period from the information on the graph. Yes? So it means that you need to find the shortest interval so that the graph of that part, by copy and pasting it repeatedly, generates the whole graph. Yes, not one part of the graph. Yes, let me just repeat. You remember, if I take this one only, it generates one part of the graph, but not the whole graph. The whole graph is important. Yes, is that clear? Let me see if I can show some of these graphs on GeoGebra or on the web. So we have to wait a little bit. So what happened? Oh, yes, Okay, let us try this idea. If it doesn't work later, I will find another way. So here, for example, if I go and type sine x, hopefully this will work. Yes. Oh, so this is Swedish keyboard. Okay, so that's also good to know about GeoGebra. So you just type here, and then let me make it x. Okay, so here you have this. By the way, this is in radians, so let me change the units, because so far we only work with degrees. So how should I do that? Probably I need to go to the properties here, graphics, and then I go, for example, to x, then I choose the units to degrees, okay, and then I will change that. So now everything in this one is in degrees. Okay, the bad point is that this is a little bit hard to understand what is going on. This is why I didn't want to start this subject before talking about radians. Okay, so I don't know why this is 6 degrees. So let me change the units, because the correct unit is actually pi. Yes. So I don't know what to say, but for the time being, remember that pi means 180 degrees. I will teach that later, okay? Because it was not a very good way of saying. So you see, pi is 180 degrees, 2 pi is 360 degrees, this is 450 degrees. So you see immediately what's happening. So a graph is repeating itself. So from here up to here is actually a period. Okay, of course, you cannot make it shorter. If I want to make this interval shorter, by copy and pasting that part, I will not be able to generate the whole graph. So that's the whole point. And if you go for cosine x, let us just draw this one. Cosine x. Cosine x. Okay, so that is also the graph of cosine x. So if I just turn this off, this is the function. You see, they are not that different. Later we will talk about why they are related like that. So essentially they say they are the same graph, except that one of them is being shifted a little bit to the right or to the left. That's exactly the same graph. So you should be able, by the way, to understand this. What is behind this? Why do you think it should be the case that the graph should be very, very similar, except that one of them is a shift of the other one? I haven't taught that yet, yes?
on y, like on sin, it becomes 1 at 90 and 270, and on x it becomes 180 and 0.
Exactly. So if you remember, sine of x plus 90 degrees is exactly equal to cosine of x. So cosine of x is exactly the sine function. The only difference is that it has been shifted by some amount. Okay? About these shifts, I will talk later. So that's an important part of today's lesson, this section lesson. But so this is very simple to understand. Yes? But my point is to be able to find some periodic functions here. Let us see if I can make an exercise for you. Okay, so just let us go here. And then here, let me write a periodic. We have ordered the keyboard. Periodic function. S, enter. And then let us go to the builder. So yeah, that's good to see them. For example, you see just a random function here. So do you agree that this is a periodic function? So this is because even if you ask me what the function is, I don't know. But by looking at the graph of this function, I see that this is a periodic function. And could you understand that this one, which is written P here, is the period? Because can I make it smaller than that? If I make it smaller than that, I will not be able to generate the whole graph. But can I make it larger than that? Definitely yes. I can take 2p's, I can take 3p's. By repeating that, it will generate the same thing. Is that understandable? Okay. But for example, which one is interesting here? This one. Is this also a periodic function? It's harder to detect. I will not give you these kinds of questions in the exam because that's just a game. But this is also a periodic function, but you need to, it takes a little bit more time to convince yourself that this is what is written one cycle is the period. This length is the period of this function. Yeah? Is that understandable? You need to sit down and convince yourself that if you want to make this shorter, it will not be able to, you will not be able to produce the whole graph. Yes? So that's also a periodic function. If I ask you, what is the period in this case? You say that if this is x2 and if this is x1, x2 minus x1 is the period. Yes? Is that clear? Let us see which ones are interesting here. I wanted to find a discrete one because you shouldn't think that everything should be... okay, so this one. Is this function periodic? Even though you will not face these functions, this function is not continuous. It means that I will not be able to draw the graph with one pen stroke. I have to lift the pen, put it somewhere else and draw it again. So this function is not continuous, but still you see it is periodic. By this number, can you read me the period exact? This is one type of questions that you will get in the exam. I will give you a diagram and I ask you by looking at this diagram, read the period. What is the period? Yes? It's 4. Is that understandable? So the period, for example, if you consider here, you agree that by copy and pasting this in both directions, I will generate the whole graph. This one, yes, this one in the middle. Then what is this one? It starts from -2, it goes up to 2. So the period of this discontinuous periodic function is 4. It's understandable? So this is a skill that you need to develop. Let me ask you, might be you ask yourself why, this is a little bit beyond the lesson, but I want you to understand why periodic functions are important, because a periodic function is related to French mathematician Fourier. Okay? He was able to show that even if I have a function which is not periodic, I can write it by adding a lot of periodic functions together. Sine and cosine functions. So in principle, if you have a periodic function which is not sine and cosine, you can write it as a lot of sines and cosines. Okay? And if you have a function which is not periodic, you can write it as infinitely many sines and cosines. So this is why actually sines and cosines are really important, not because we just want to study the motion of pendulum or whatever, but even if the motion is not periodic, you can still write the equation of motion in terms of sine and cosine functions under some conditions. Yes? So that is why it's really interesting to study the properties of sine and cosine function. So that is why it's a more or less a long section in the book talking about the properties of sine and cosine. You might think that, so what I'm saying is that, is this graph somehow similar to sine or cosine? This graph. It's not. Yes? It's discontinuous. But I can find sine and sine cosine functions with different arguments in front of them, so that when I add them up, the graph of those functions become closer and closer to this graph. So this is why the most fundamental the most fundamental periodic functions are sine and cosine. Because all other periodic functions under some very mild conditions can be written in terms of sine and cosines only. So this is why it's very important to study and understand sine and cosine functions. Yes? I don't see any interesting thing more or less here. So for example, let us look at this graph. What do you think? Is it periodic? And if it is, yes, it's not bigger here, but I hope that you can see. No, you cannot see it properly. Yes. Yes. No, I cannot find something interesting, but hopefully you understand what I mean by a periodic function. By the way, you look here, this is something like that. If you have these functions, are these functions periodic? So you see, these are very similar to sine and cosine functions. Sigma means sum. When you add these diagrams, you generate this diagram. Okay, so that's what that's a little bit of intuitive way of understanding things. You see here, this function is a step function. These up and downs are sine and cosine functions. You see, by adding them up, I am getting closer and closer to this step function, even though it is really sharp. I will try to find some demonstrations on GeoGebra to show it for you. But if someone asks you why we are studying sine and cosine so heavily, it's because every other functions which are periodic can be written in terms of sine and cosine only. So if we know the properties of sine and cosine, we can discover a lot actually about other functions as well. Okay. So, I don't know when the lesson ends, do you know? 15? Okay, in 15 minutes. This part is unfortunately not finished, but we can demonstrate it here. Let me ask you one question. Let me close this. What do you think will happen if I multiply sine x by 2, for example? I want you to predict what will happen. I want to multiply sine x by a constant 2. This is my question, so let me use it here. So here you have, let me write here, f of x is sine x. You have the graph. What will happen if I have another function which is 2 times sine x? Do you think the graph of this would be very, very different with this? Or how you can understand the graph of this by having the graph of this? Then I want to test your understanding. That is also one part of lesson, but next time I will make it more formal. So what will happen, do you think, if I put a 2 behind sine x? Let me ask you, will it be stretched up or squeezed up and down, or stretched up and down, or it will be stretched left or right, or squeezed left or right? This is the effects that I want you to tell me. Will it be stretched or squeezed? In which direction? Yes, Ruben?
Stretched upwards.
Stretched with a factor of 2 upwards, yes? Upward and downwards, yes? So the positive ones will be 2 times larger. The negative ones will also be 2 times larger in the negative direction, yes? So then you can see that what happens. But do you think there would be any stretch on this x and y axis? X-axis? So it means that if this green graph is actually pointing here and passing through these points, minus 3 pi, minus 2 pi pi, what is your prediction about the new curve? Does the new curve also pass through these points or different points? Yes? The same points or different points? Yes? The same points. Because you told me that it will be stretched only in the vertical direction, but it will not be affected on a horizontal direction. And that's right. Let me just type it for you to see, because I want to make a different one. So, okay, let me write it with keyboard here. So y is equal to, so let me change the Swedish keyboard to English one. So y is equal to 2 times sine, yes, and then I would put a pair of brackets here, x, then I have that. So that is your prediction was right, yes? So you see, the highest point was 1, now the highest point reaches to 2. The lowest point was minus 1, now the lowest point is minus 2. But you see that the new graph is also passing exactly through the same points on the x direction. So your prediction was correct. A little bit counterintuitive way is what happens if I multiply x by 2. Okay? So let me draw another, let me ask you this question. H of x is sine, instead of multiplying 2 by the whole function, I multiply 2 by x. What do you think this will happen? This is a little bit counterintuitive. First of all, do you think it will affect the heights or not?
Yes.
So let me ask you, if I ask you what is the maximum value of sine, answer this question. What is the maximum value of sine x? What is the maximum value? What is the maximum value of sine x? 1. What's the minimum value? Minus 1. No, minus 1, 1. Yes, you see that. The top part of the green graph is at most at height 1. Yes, at height 1. And the lowest one is at height minus 1. So the maximum is 1, the minimum is minus 1. If I ask you the same question, what is the maximum of this function, what is the minimum of this function? 2 and minus 2. Now my question is that, what is the maximum and minimum of this function? Again, 1 and minus 1. Be careful, because if you say the maximum of this is 2, then it is wrong, because sine of no angle can be 2. Sine of any angle should be at most 1, at the lowest minus 1. So if you multiply the sine by 2, of course you are increasing the max. But if you multiply this by 2, you cannot affect the max, because the max of sine is just sine. It cannot be, so the unit circle is the unit circle, you cannot go above that. It doesn't matter how many you go around. Yes? So sine 2x shouldn't be higher than the green curve, shouldn't be lower than the green curve. But it cannot, of course, be the same green curve. So how it will change? You should be able to think and answer that. Yes, Jesse?
Doesn't it get up?
The height, you mean?
No, the x-axis.
So it would be squeezed, you mean? Yes, by a factor of 2. It would be squeezed by a factor of 2. So let me just check that one as well. So if we go here, so let me write y is equal to sine of pair of brackets 2x closed. Oops. I made a mistake. Okay. So that one, let me get rid of this. So that would be the new graph. So the green one is the old one, but this purple one is the new one. And you see that the heights are the same. The higher one, the lower one are still minus 1 and 1. Agree? But what is happening here? this green curve was stretched, the period of this green curve is from here to here 2 pi. Now can you read for me the period of the purple one? The period of the purple one is pi. So the period is half of the period of the previous function. So remember this as a rule of thumb. We will talk a little bit about that later. If you multiply a function by a number, the effect would be on the vertical direction, and it is normal. It means that if you multiply by a number larger than 1, you stretch it, and of course I can check. If I multiply it by 1/2, I will squeeze it. Okay? But here, this is the opposite way around. If I multiply x, I will squeeze or stretch in the horizontal direction in the unusual way. It's a little bit strange. You expect by multiplying by 2, you should stretch it 2 times, but no, you squeeze it 2 times. Yes? And if you multiply it by 1/2, then you stretch it by 2 times. So, multiplying the function by a number and the angle by a number have quite different effects on the graph. Yes? This is something you have to know. This is actually part of your lesson. Okay? But because it is a little bit lengthy lesson, I will stop here. I will continue this one again. Okay? And then go to the next lesson. Any questions? Thank you very much. And have a nice weekend, by the way.